As I indicated before, during the launch, that I had in my hypothetical mind set up that the balloon would travel horizontally and vertically roughly a meter during launch, and that this velocity was about appropriate for the flight. That what you'll notice as I get down here between 2.2 and 2.3 seconds, that you see how the y position goes from positive to a negative. So what that means is somewhere in between here it actually hit the ground, because the ground is actually at 0. Now you can also make an estimate that it was much closer to 2.2 than 2.3, because this is just roughly 2/10 of a meter above the ground, and this is almost a meter below the ground. And in week 7, I'll show you a way we can fine tune this further. But that's how I decided where to cut this one off. In a similar fashion for the landing, that if you look, that in terms of velocities, that what we have going on is that the x velocity is positive until it comes to a stop, and then you see this last row here, row 12, has a negative value. In a similar sort of fashion, the y velocity goes from being a negative to being positive, which would be true if it bounced off the ground, but we're going to ignore that. So anywho, that this was a good place to cut this off, because we know that between row 11 and 12 is where we had things happening. That's where the balloon actually came to a stop. And so what I'm going to do now is I am going to go back. I went to the launch, and I am going to select the time and the position. And on a Mac, I use the Apple key when I select, because I don't want to select everything. And I think it's the control key on a PC that allows you to select these various kinds of things. And then what I'm going to do is I am going to insert a chart. And when we're doing this kind of stuff, as I've talked about in the past, we're going to use XY scatter. And the one I typically use is that one. And you'll see right here that it just looks like it's 1, and that's because they're identical. Yours won't be identical because none of you shot at 45 degrees, so your initial data is going to be slightly different, so you'll actually see both the blue and the red. It's just that they're right on top of each other. Now I would go through and using the title part of it here, give it a title. I usually get rid of the, well, yeah, I guess you have to, but then I would label the axes, because the horizontal is time and the vertical is meters, etc. So that's my position versus time. And then I would go back and do the velocity versus time graphs, and you're going to see the same sort of thing, that I guess it is make me, because it's different than Windows. Okay, so there you go. And that's the way you would expect it, except that if it's not exactly 45 degrees, they'd be at different angles. And again, I would go ahead and make use of the appropriate titling for both the sheet, for the graph and for the axes. And then the last one you would do is to go ahead and do it for the accelerations. And of course, you'd see something similar to that. And so you would do this for all 3 sheets, and then you don't need to include the data table from Excel in your final document, but you could include each of the graphs in each of the 3 faces. So if you got any questions, let me know, but other than that, I think you got it.